Okay, we're live. Here we go. So today's date, Diciembre 7. Diciembre. Oh no, November. Oh my goodness gracious. Thanks, Bailey. Yes. 7 Noviembre 2021. Okay, so today, what's our objective? Today we want to be able to find the equation of exponential functions. Okay? Write that down, please, while I get the phone. Hi, Karen. Yes. Yes. No, Heather's not here. Fine. Okay, here you go. So, we know, okay, if it's a linear function, like Tava said, it's straight. One equation is y equals mx plus b, or we could use the y minus y1 equals m times x minus x1. You're probably going to use this y equals mx plus b more and more as your math progresses. We use this one a lot because it's easy to graph. You start at, okay, you start here, b, whatever b is, the y-intercept, and then you apply the slope, right? You know that, right? So this, whatever this number is that, and then the slope, right? And that's the easiest way to graph a straight line. So let's put that information down. We know that this value right here is our b, called our y-intercept, and we apply our slope, and m is a slope, rise, over run, like walking up the stairs, right? Exponential is different. It curves. It has the J shape, right? And it has this equation, or this equation. 1 plus r to the t, depending, okay? So, when do you use one and when do you use the other? I use this one if it's like, they say it's a percentage increase. So I use what they say is growing at, say, 8%. I use this one. Or if it's shrinking by like 5%. So if I see a rate, like percentage rate, I use this one. If it says that the rabbit population doubles, with me, doubles every day, I put a 2 there. Does that make sense? That's why it's starting. If I have like 100 rabbits, and they double every day, I use a 2 there, okay? If I had a bank account and they said it grows at 8% per year, I'd put 0.8 or 0.08 there, okay? You see where I'd use the 2? Same equations, really. Depends on the question. All right, now, let's take a look at example 1. So if we can see it, a lot of times it helps, okay? So I'm going to graph. This is pretty easy. I can graph this. I'm going to go 0, 1. That's right about there. 2. -2, 4, 1, 2, 3, 4, and -5, 1, 2, 3, 4, 5, and -4, -7 is way down here. Okay, so it's off my page, but I'm kind of thinking it's what? What do you think it is? I think it's linear, right? So if it's linear, then it should have a slope, right? And the easiest way to find the slope, there's lots of ways. There's lots of ways. What's the easiest? Let me see a real easy way to find a slope. Walk the stairs. Press it.
Like where it's -2 and 1, or 1 -2.
Yeah.
You can just, or 2 -2. You can just go up and then over 2.
Right. So you could use the formula. Remember the formula y2? You could use it. The formula works. Or, since it's on a graph, it's just down 3 over 2. See that? That's what Price was saying. It's so much easier. You guys agree? What? You're going to go down 3 over 2, down 3 over 2, down 3 over 2. So the slope's just down 3 over 2, right? That's the easiest way to graph. If you can do that and find the points, I want to say the slope is
down 3 over 2. And I know my y-intercept is right there. There's my b, right? So the equation I'm going to use is my y equals mx plus b. Okay. And I'm going to go y equals my slope, which is negative 3 over 2x, and then plus 1. How's that look? Pretty easy. We've done this lots. Okay, example 2. Well, let's graph that and see what it looks like. Okay, so I'm going to go 0, 2 is there. 1, 1, 2 and 1/2. Negative 2 and 8. 1, 2, 3, 4, 5, 6, 7, 8. And negative 1, 1, 2, 3, 4. Okay?
Well, what do you think? Is it linear or exponential?
Exponential.
Yeah, definitely. You guys can see that shape. It's got that J shape to it, right, Jay? So it looks like that. I like the asymptote because it shows that it never touches that line. I like my asymptote. Funny word, huh? So the ratio, what's going on? What's going on from point to point to point? What's the ratio? What's happening? Do you guys see what's happening from here to here to here to here to here to here? What's the ratio? Tava, what's the ratio?
1/2.
Yeah, so the ratio is 1/2. So the equation y equals ab to the x is going to be y equals, now the a is right there. There's my a. So my a is 2. Okay, it starts, has a y-intercept of 2. B is my rate, which is 1/2 for my ratio to the x power, because I need it exponential, okay? How am I doing, okay? Maisie gave me a thumbs up. Any more thumbs up? I saw one. There's more thumbs up. Okay, good. Make me happy there. Thank you. Okay, turn the page. Now, there are two ways to do this. Some kids really like to just graph it and see it. And that's okay. So I think sometimes it's easier to just do a really rough graph, right? So on A, let's see, I'm going to have -2, -1, 0, 1, 2. Oh, I'm going to need more of a graph, aren't I? Okay, I'm going to have to make this graph go further down. Wow. Wasn't anticipating all the way to -7. 1, 2, 3, 4, 5, 6, 7, 8, 9. And okay, so then -7, huh? 1, 2, 3, 4, 5, 6, -7. Okay, graphing doesn't hurt. It's kind of the long way to do this, but I can do it. Okay, I went -2, -9, -1, 5, 0, 1, 1, -3, 2, -7. All right, what do you think? Yeah, I definitely think it's linear. I definitely think this is linear. Okay. I would agree, linear. Now, another way from a chart is to see what's going on. It goes up by 1, up by 1, up by 1, up by 1. It goes down by 4, down by 4, down by 4, down by 4. So if I look at the chart actually gives me my slope. So every time it goes over 1, it goes down 4. It goes over 1, it goes down 4. So I know my slope has to be -4, okay? And my y-intercept has to be +1. There's my b at positive 1. So if I know it's linear, I'm going to use y equals mx plus b, because that's my linear, right? So I'm going to use this formula, and I'm going to go y equals, my slope is negative 4x, my y-intercept is positive 1. How am I doing? There's 2 thumbs up, 3, 4, 5, 6. Good. Thanks, you guys. All right, let's take a look at B. So what I see about B, just from the chart. Anybody see anything from the chart before I even do it? Yeah, what do you see, Preston?
Adds 1 every time.
Okay, we're going to add 1. So plus 1, plus 1, plus 1, plus 1. Good. What about the y's? Okay, here we go. Multiply by 3. So if I multiply by 3, it's not linear. You guys agree? It's going to exponential. It's got to be exponential. And you can graph it, and you'll see it. If you did a rough graph of it, it's going to look like this. It's going to look like... Okay, it will be if you graph it. It's going to look like that. So I'm pretty sure it's exponential. So, what's the A? Can you see from the chart? What's the A from the chart? It's the intercept. And that chart shows you, what is the intercept?
9.
It is 9. Okay, the A is 9, because 0, 9, right? Right? Okay, what's the rate? What's the B? 3, because you times by 3, times by 3, times by 3. So my equation's going to be, all right, I can do this, y equals A, which we know is 9, times 3 to the x power, okay? And I'm going to say it again. Okay, prepare yourself for Mr. D's being a fool, crazy boy. Crazy man. This is 3 to the power of x, right? Everyone, don't do this. I'm going to be so bummed. That is not 27.
Yeah.
Do not make that 27. That's not. It's 3 to the x, not 27 to the x. Do we agree with that?
Yeah.
If you make that 27 to the x, I'm going to be so sad. I'll say you didn't pay attention because, my goodness, I've said it how many times? It's not the first time I've said this. You guys agree? So if you don't, if you blow that on a test, I'm going to be so sad for you. I say, well, guess we'll just do algebra again. All right. Okay, now, average rate of change. So before I tell you what the average rate of change is, let me go ahead and give you an example, okay? So when you take a road trip, and you drive from here to, say, Spokane, right? Your speed changes. I mean, it really does. You drive along for a while, and you slow down because maybe big trucks, you speed up. Maybe you have to take a bathroom break, but you'll say, what was the average? What was the average? So to do the average, you take a look at how far you went in what time, right? So maybe your average is 50 miles an hour. Does that mean you went 50 the whole time? No, it's just an average, right? Does that make sense? So when you look at these, we want an average. We're going to get an average using basically the slope formula. Okay, so this is curve. So the average changes. Does that make sense? So the speed here is slower than the speed here. And the same thing's going to happen here. The speed here is going to be slower than the speed here. But what's the average over the period of time? So how you do the average rate of change? It's just simply, it is like the slope formula. So let's take a look at it. Find the average rate of change from day 10 to day 20. Okay, so let's take a look at website A. All right, so day 10 has 1,400 members. Okay, let's circle that. There's day 10. Day 20, I'm going to circle that, has 2,150 members. Okay, so I'm just going to take a look at my charts. Now let's figure out its daily average rate of change. So I'm going to go 2150 minus 1,400 over 20 minus 10. Okay, what did I do? I'm just doing the slope form, okay? Wrote down my 2 points, x1, y1, x2, y2, right? See it? x1, y1. And then I just went, okay,
this minus this, over this minus that. Okay, I'm just gonna use a calculator, I get the answer. Now tell me my average, just an average, okay, so let's see here. So let's see, that's gonna be, calculator time, 2150 minus 1400. Gives me 750 over 10, or 75 members per day, okay, per day. That doesn't mean it's always going to be 75. That's just the average. That makes sense? 75 members per day does not mean every day it's going to be 75. I'll say it again. 75 members a day does not mean it's always going to be 75. Agree? Let's check out the other one, okay? Now, day 10. I'm going to have to use my chart. Day 10 is there. And day 20 is there. So day 10 looks like we're at about, I think 800. And day 20 looks like we're at about 1800, right? Okay. All right, so average rate of change, I'm going to go 1800 minus 800 over 20 minus 10. And then I could say that is going to be 1000 over 10, which is 100, okay? So which one's growing faster?
Well, wouldn't number 10 be 900? Because, yeah, because 1200 and 600, that's a 600 change now.
Oh my goodness. Thanks, guys. See, Preston, thank you.
But like on a test, that wouldn't matter, would it?
No, I wouldn't count it wrong. I mean, if you, yeah. 900, thank you. That's going to be what, 1100? Thank you, Preston. Okay, which one's growing faster? Obviously, membership B. And again, that's just an average. That doesn't mean there really were 110 people that came on every day. It's just an average, okay? All right, so homework. We got lots of time to get it done. We really do. Okay, so what you guys do? Page 171, 1 through 9. All I want everybody working on this. Okay, everybody. No cell phones out. We're gonna get this done in class. No whining about homework at home, right? Stop recording.